Welcome back at C-Square. In this lesson we will talk about dilation, which is a non-rigid transformation. Uh, I said here is a transformation that changed the dimension of the original shape, the pre-image, how it's called. And you see here the first one is what we call an enlargement. This is the pre-image and this is the image, and you see it is larger than the original on the pre-image. And the second one is what we call a reduction. This is the pre-image, this is the image is smaller than the original one. As you notice in the previous figures, we have those points D, those are called the center of dilation, this one. And we have what is called a scale factor of dilation, okay, which is greater than 1 if we have an enlargement like this one here. Oops, greater than 1. And in this one, when we have a reduction, it's less than 1, but greater than 0. It's between 0 and 1 in other words. And let's take a look to this first example where we have to determine whether each dilation is an enlargement or a reduction. And if you take a look here, it says from A, B, C, from this guy to D, E, F. So if you notice, we go from a large one to a small one. And the question is 6 times what? Will be 3, and that will be 1/2. So that what it is, the scale factor. Okay, so we have a reduction here, and the scale factor is 1/2. On the second one, we're looking from the triangle NMP, the small one, to triangle TRS, the large one. So obviously this one will be an enlargement, and the scale factor will be 4 times what is 8, and that will be nothing else than 2. That is the scale factor. So we have an enlargement, and the scale factor is 2. On my next stage of the lesson, we're gonna look to what I said, the dilation in the coordinate grid. And you notice here we have the pre-image, the small triangle here, and the image, the large triangle. So obviously, if you take a look here, we have an enlargement. And by the way, this is the center of dilation. The center of dilation in this case is the origin. And on this next figure, you can see something else that sometimes is very useful. You can see this ray OB prime or OB, either way you can call it, it is not a problem. We see all these points are collinear, OB and B prime. The same for OA and A prime, and OC and C prime. That is something that we're going to use in this lesson a little bit later. And here you notice also I said there is a rule that can be used for doing a dilation of scale factor K when the center of dilation is at the origin 0 and 0. And you see it right there. So let's see now an example. If you notice here we have triangle ABC, and we need to find the coordinate of the triangle A prime, B prime, C prime. If this one is dilated by a scale factor of 2, so K is 2, and center at the origin 0 and 0. Since we have this center at the origin, we're gonna use the rule. Is the easiest way in my opinion, and the rule, if you remember, is this one. Okay, so let's take every single point. We're going to start with point A. A has the coordinates 6 and 2. We're going to enlarge by a scale factor of 2, a dilation by a scale factor of 2. I'm going to write it like this, and A prime will be these two, the scale factor, that is the K, times the x coordinate times the 6, And very similar for the y coordinate, the same too, the scale factor now times the y coordinate too. And we can simplify what we have here, and we end up with a prime being 12 and 4. So this is the new point if we dilate by a scale factor of 2. Let's move to point B now. If you take a look, the point B, this one is 0 and 4. Again, we have a dilation by a scale factor of 2. That B prime is going to be what? So if in your mind you're going to say 2 again, the scale factor, that's correct, times 0, right? This is kx. And now ky, so 2 times 4. So the final form we're going to simplify here is going to be 2 times 0 is 0, 2 times 4 is 8. And now let's take a look to the last point here, C, which is this point, and we have the coordinates 2 and 6. Again, we're going to dilate by a scale factor of 2. Again, I'm going to write it like this. Center of the origin, very important. So we have C prime, and that will be again the 2 from the scale factor, right, the k, times the x, which is 2 in this case. And now for the y coordinate, the same thing, k, which is 2, times the y, which is 6. So the final answer for C prime will be 4 and 12. And that's it for this problem. You can see also here the graphical approach, and this is the pre-image, and this is the image. Okay. And you notice the coordinate match what I have here. Good. This one is the same triangle, but now dilated by a scale factor of 1/2. Again, still center of the origin. So again, the scale factor is 1/2. Let me write it here, center of the origin. And now we're gonna do the same thing. We're gonna have the same rule. X, y becomes kx, ky. So let's see what we get here. We're going to start again with point A, which if you remember was 6 and 2. What will be A prime? A prime is going to be this k now, be careful, 1/2 times the x coordinate times 6. And the y coordinate, the same thing, the same scale factor of 1/2 times the y coordinate, which is these two. We can simplify here, which I'm going to do it in the next step, when we have a prime equals 1/2 times 6. Let me put parentheses instead of equal, and that will be 3, and 1/2 times 2, that will be 1. So we finish with a prime. Very similar, we're going to do b. If you remember, 0 and 4. Again, b prime will be what? It will be k, which is 1/2 times the x coordinate, which is 0. And then comma, let's move to the y coordinate, the same scale factor, 1/2 times the y coordinate, 4. So we get here b prime is 1/2 times 0 is 0, 1/2 times 4 is 2. And we have one more point, point C. C, if you remember, is nothing else than 2 and 6. So we have C prime, which is 1/2 times 2 and 1/2 times 6. So for the x coordinate and the y coordinate. So we end up with C prime of being 1, and 1/2 times 6 is 3. And that's it. Very similar. You can see this dilation, this reduction here. This is the pre-image, this is the image, and you notice A prime 3 and 1, B prime 0 and 2, C prime 1 and 3 in this picture. Now, like I said in a couple minutes ago, we can take a look to these rays. You see them here better, and you notice OB, B primes are collinear on the same line, OA, A prime are collinear on the same line, and the same for OC and C prime, they are collinear. So That fact is going to help us with a problem like this one. You see here, triangle A prime, B prime, C prime is the image of triangle ABC. Describe the dilation and write the coordinate rule to describe it. So my first thing on this type of problem is to draw those rays. So you notice we don't have that O, but we by drawing the rays we can find that center of dilation, right? So look at here, I'm gonna draw this ray that goes through A prime and A. Oh, that is in this case the x-axis, of course, kind of a special case. The same, we're gonna have a second ray that goes through B prime and B, and you notice these two rays meet in this point. This is the center of dilation, that O or D, whatever we're gonna call it. Okay, and by the way, if you go and draw a ray or a line between C prime and C, you will see it gonna go through O. I'm gonna try to do that. I might not be successful on my screen, but you can do on a graph paper and you'll notice all these three lines meet here. This is the center of dilation. Okay, the center of dilation is O. It's 0 and 0. But now another thing that we really need to be aware about the dilation is the scale factor. So how are we going to do that? So you may want to take a look to maybe AB and A prime, B prime. And sometime if you look, you can see the scale factor. And well, let's take a look here to a way to approach this problem, one way. So you see, from going to A to B, I need to go 1 up, 3 right. Let's do that here. I'm going to go 1 up, 3 right, 1 up, 3 right, 1 up, 3 right. So I follow the same pattern. So I have 3 segments here that are congruent with A prime, AB. So in other words, A prime, B prime is nothing else than 3 times AB. So that tells us the scale factor, K is 3. That is one way to take a look. Another way is to take a look to something like this. OB is 1. OB prime, it's 3. That also should tells you the scale factor is 3. And another way to do it, special when the numbers are not friendly, is to really take a look to the coordinates. For example, C, I'm going to use C, but you can use any point, has the coordinates -1 and 2. And C prime has the coordinate -3 and 6. So now looking here, how do I go from -1 to -3 by multiplication? By multiplying by 3. Let's check if that works for the y coordinate. 2 times 3 is 6. So one more time we notice this is the scale factor. So more ways to take a look. So now we know is a dilation by a scale factor of 3. So the rule and center of dilation is the origin. The rule is xy is 3x, 3y. Okay. In this next picture, you can see whether the rays, the ray that goes through C prime and C, and I call the center of dilation D, but you can call it O. It really does not matter. Right here I said that you can do dilation with respect of any point. You do not really have to have just the origin. And you have here 2 cases. So by the way, this is the pre-image and this is the pre-image and this is the image, and you notice this is the center of dilation, right? It's not the origin, it's somewhere. Okay, so you can have this case, but you can have also this case you see here where the center of dilation is one of the vertices of the triangle, in this case the point A. And now you notice A prime is going to be in the same spot as a or the center of dilation. These are the two cases you can get. Okay, so let's see an example like oh, by the way, this is a description how to dilate. If you want to really do this way, maybe graphically or going step by step, you can move the picture, you can translate the picture such that this center of dilation will be the origin. So obviously the triangle is going to move, then you dilate and then you move back where the picture was. But another way to do it is this way, where you have this formula. I think is the best way to do it. So I'm going to show you now an example like this one. Triangle ABC is shown below. Find the coordinate of triangle A prime, B prime, C prime if the triangle is dilated by a scale factor of 1/2. And the center of dilation is 2 and 1. Now, let's write that formula I had before and let me describe a little bit. XY becomes what? KX minus M plus M. So remember we have a parenthesis here, very important, and very similar, K times Y minus N plus N. So ladies and gentlemen, you notice we have K, which is the scale factor. What are these M and N? This M is 2, the X coordinate of the center of dilation, and N is nothing else than 1. So that we have now everything we need to move on to get the points. So let's start with A. The point A has the coordinates 2 and 4. And let's see what we get for A prime. Okay, so again, you may want to go slow. K, you notice that is 1/2. Then we have X minus N. X is this guy, the X coordinate of point A. So it's going to be 2 minus 2 plus M again, 2. So go slow in my opinion. The same for the Y. K 1/2. Y is the Y coordinate of the point. 4 minus 1 plus 1. And let's close this order pair. So now let's do some simplification here. A prime will be 2 minus 2 is 0, so we have 1/2 times 0. And I'm sorry, we have that plus 2. Let's not forget about that. Okay. And let's go to the second part, the Y coordinate. We have 1/2, 4 minus 1, that is 3. So 1/2 times 3 plus 1. Okay, and let's see now if we can get the point. 1/2 times 0 is 0, plus 2 is 2. What about this one? 1/2 times 3 is 3/2. Plus this one, that is 2 over 2. How much is 3/2 plus 2 over 2? That is 5 over 2. And that's it for point A prime. Let's move to point B, where we're gonna do similar math. The only difference, point B has different coordinates. We have 5 and 7. The formula is the same, so B prime becomes what? K, which is 1/2, the same 1/2, parentheses, X minus M. X now is this 5. 5 minus M. 5 minus 2. and then plus m plus 2. And let's move to the next thing. Well, y coordinate 1/2 again. The scale factor y is 7, 7 minus, and n is 1 plus 1. So let's see what we get here. B prime is 1/2 times 5 minus 2 is 3 plus 2, and the y coordinate 1/2, 7 minus 1 is 6 plus 1. I think we need one more step. 1/2 times 3 is 3/2 plus 4 over 2, that will be 7 over 2. And here we have 1/2 times 6, that is 3, 3 plus 1 is 4. Okay, now we have one more point, the last one, C. So let's see, C is 8 and negative 2. And let's see what C prime is going to be. C prime will be 1/2. Again, the scale factor, the x coordinate now is 8. 8 minus 2 dm plus 2. The same for the y coordinate, 1/2. Now be careful, the y coordinate is negative 2 minus m minus 1. Let's close the parentheses, plus n plus 1. Let's see what kind of simplification we can do here. 1/2 times n minus 2 is 6 plus 2, and let's go to the y coordinate. 1/2 negative 2 times negative 2 minus 1 in fact is negative 3 plus 1. So one more step here, and again this is C prime. C prime 1/2 times 6 is 3 plus 2, that will be 5. 1/2 times negative 3, negative 3/2 plus 2 over 2, negative 1/2. I have here the picture. Let's double check if the graphical approach match this algebraic one. A prime 2 and 2.5. Yes, that works fine. B prime, it is 3.5, 7 over 2 and 4. That's correct. And C prime, it is 5 and negative 1/2. So yes, it is correct algebraically and graphically. We have the same answer. In this next example, we're gonna have another dilation, but now take a look. The dilation is one of the vertex, this one of the vertices in the vertex A. So the scale factor is 3, and the center of dilation is A, which has the coordinates negative 1 and 3. That means M is negative 1 and is 3 in that formula. I'm going to put the formula right here. X, Y becomes, write this formula for a while, is going to help you to remember K. X minus M, this is in parentheses, don't forget, plus M, and the Y coordinate K. Y minus n in the parentheses plus n. Like I said, if you write this formula a couple times, then you will remember. And now let's start with A, or A. In fact, you don't have to do anything. A is negative 1 and 3 is gonna stay the same. You can use the formula if you want. You will see it. You end up with the same point. Why? Because that is the center of dilation. Let's move to B, where we have to do work now. Point B is 1 and 4. So let's see what B prime will be. Again, dilation by a scale factor of 3. So we're gonna have k is 3. Then we have x is 1 minus m minus negative 1 because m is negative 1. So be careful here with these parentheses, and then plus m plus negative 1. Let's move to the y coordinate where you have k again, 3, y minus n, so that will be 4 minus 3 plus n plus 3. So let's do some simplification here for b prime. 1 minus negative 1 is 2, so you have 3 times 2, and plus and minus becomes a minus 1. Let's move to the y coordinate. We have 3 times 4 minus 3, that is 1 plus 3. And I think we can get the answer in the next step. B prime will be 3 times 2 is 6 minus 1 is 5. And 3 times 1 is 3 plus 3 is 6. So that is B prime. Let's move to C. Point C, if you have noticed, the coordinates are 2 and 1. Let's see what C prime will be. Again, the same formula where we're going to start with K, which is 3, x minus m, 2 minus negative 1. Here, be careful. Plus m plus negative 1. And again, here it's this guy. Okay, and then we're gonna move to the y coordinate. The same thing. We have the scale factor of 3. Y minus n, 1 is the y coordinate, minus 3. And then plus n plus 3. Again, don't forget the parentheses signs, very important. So let's see now. C prime will be now 3 times, we have here 2 minus negative 1, that will be 3 minus 1. And let's move to the y coordinate. 3 times 1 minus 3, that will be negative 2 plus 3. So let's finalize this C prime, and we have 3 times 3, it's 9 minus 1 is 8. And the y coordinate, 3 times negative 2, negative 6 plus 3, negative 3. And that's it. I do have here a graphical approach, you can see it. Let's double check. You notice A prime is the same of A, like I said. B prime, we have 5 and 6, yeah, that's correct. And C prime is 8 and negative 3. So the graphical match the algebraical, and you see how it looks, this dilation. Very interesting, right? Okay, very similar. We have here a dilation. We can see that we go from ABC to A prime, B prime, C prime. So guess what I'm gonna do? I'm gonna do something very similar we did before. We're gonna draw these rays, right? We're gonna start with C, C prime, this one, and you know, I don't know where that is, so I'm gonna draw it like this. Now I'm gonna look to A prime and A. So you notice this one, I have to go 2 right, 1 down, something like this. If I do the same thing, where am I at? I'm right here. That is the center of dilation, right? And I can follow this in case you want that. But for you, it's going to be easier if you have on the graph paper, just use a straight edge, a ruler, and you're going to get it. And if you do the same thing for B prime and B, if you notice, you have to go 3 and 2. 3 and 2 to connect this guy, 3 and 2 is going to be exactly in the same point, right? So you notice this is the center of dilation D or O, whatever you want to call it. The center of dilation is 6 and 0. Now the thing you want to look at also in the picture, if it's possible, is to get the scale factor. So you have choices. If you remember, let's try to do this one, since this is our horizontal segment. Let's take a look. DC is 1, 2, 3, 4. So DC is 4. And now let's take a look to this one, C prime D or D C prime. That one, if you take a look, will be, let's count, 1, 2, 3, 4, 5, 6, 7, 8. 8. How do I go from 4 to 8? By multiplying by 2. So now we have everything we need. Everything we need. We have the center of dilation. We have the scale factor. So let's go here and write this formula that we had before. So again, K times X minus M plus M, and K times Y minus N plus N, right? This is the formula, and we can just plug these things in. But by the way, let me say that this is an algebraic way. Of course, you can do, I'm sorry, this is a graphical. We can do an algebraic way. Just take the points A, B, and C, A prime, B prime, and C prime, plug them in, and solve for M and K. So it is an algebraic process, which is not very easy. It takes a little bit of time. But now we have it, so I think we can go and just fill in the blanks here. So if you remember, K is in fact 2, the scale factor, X minus M, X minus the center of dilation is 6 and 0, so M is 6. And then let's do the same for, oops, no, the scale factor is 2, so we can replace it. Sorry, we can replace it 2 times Y minus N. Y minus N is 0, right? Because the center of dilation is 6 and 0. Y minus 0 plus 0. You can simplify this if you want, and we get a rule like this: 2 times X minus 6 plus 6. Of course, this one can be simplified also, but I think the next one is the one that you want to simplify. This is the rule. So you can take the point A, you see here, apply the rule, see if you get A prime, and the same for B, and B, see if you get B prime, and so on. Okay, here hopefully you can still see it. You see what I did on the left side, but just in a better shape. Again, a graphical way would be here very useful in my opinion, instead of an algebraic way. My next part of the lesson will be about composition of transformation. If you notice here, we have a rectangle given. This is the same for the rectangle in rectangle ABCD. We can see that here. Picture below. This rectangle is rotated 90 degrees clockwise and dilated by a scale factor of 2 centered the origin, and we get this rectangle A second, B second, C second, D second. Find the coordinates of that guy. So we're gonna go and grab the coordinates of point A, and that is -6 and 6. And the first thing you wanna do is to rotate 90 degrees clockwise. I'm gonna say here, rotate 90 degrees clockwise. That's one way to, I guess, write it around the origin. Let's say like this. There is an algebraic way to do it, which says, I'm gonna put it somewhere here, xy becomes y negative x. You notice we switch x and y and we change the same sign of x. This is rotation. (90°) clockwise around origin. And I'm going to use this rule for all 4 points. So A prime, which is B, going to be point A rotated 90° clockwise, will be what? Switch x and y. I did it. Change the sign for x, so make it positive. That's the same for B. B is -6 and 4. The same rotation. B prime will be what? Switch 4 and -6 and change the sign. Let's go to C. C is -2 and 4. Again, what will be C prime? Switch 4 and -2 and change the sign. And D, the last one, the same rule, because we rotate still 90° clockwise. D is -2 and 6. All be D prime. D prime will be switch 6 and -2 and change the sign. So we finished the rotation. Now we have the other one, the next transformation, dilation by a scale factor of 2. So if you remember, what is the rule there? We're gonna multiply by this 1/2. So what do we get about a second, right? We have 6 times 1/2. 6 times 1/2, I'm gonna write it here. That would be 3. The same thing here, 6 times 1/2, 3. Let's move to point B prime. We dilate it by a scale factor of 1/2, so we have 4 times, let me write it one more time here, I think it's worth it. 4 times 1/2, 4 times 1/2, that is 2. Then we have 6 times 1/2, that is 3. We did that already. Let's move to C prime, and again the same dilation of a scale factor of 1/2. The one will be C prime. Then I have 4 times 1/2, we did that, it's 2, and 2 times 1/2, that will be 1. And we have one more point, point D prime, and by the way, this is B second, C second, and this one will be D second. Okay, so again we have 6 times the same scale factor of 1/2. 6 times 1/2, 3, we did it, and 2 times 1/2, it's 1. That's it. This is the final result, and you can see a graphical approach here. Also, we can double check and see if we have this answer correctly. You notice A prime, 3 and 3, B prime, I'm sorry, A second, B second, 2 and 3, C second, 2 and 1, and D second, 3 and 1. So yes, it is correct. So go slow, and of course sometimes it's very useful if you remember the rules for different rigid transformation: reflection, rotation, translation. My final problem is this one. Sometimes you do have the two shapes, right? We notice we have the triangle ABC and triangle MNP, and you need to find the sequence of transformation that maps this triangle ABC to triangle MNP. So we need to go from this big triangle to this small triangle. So obviously, looking here, we know we have for sure a dilation, a reduction, right? What will be the scale factor? Let's see if we can see it. I think it pays off if you take a look where BC, this segment, BC, this segment is 2 units long. The corresponding one will be NP, which is 1 unit long. 2 times what is 1, and that will be 1/2. Ladies and gentlemen, that is the scale factor. The scale factor K is 1/2. The dilation is a reduction, and the scale factor is 1/2. Easy to see it in the picture. Okay, now let's try to do that reduction, that dilation first. So how am I going to do that? And by the way, I will say dilation and center of dilation, origin. Okay, so I'm gonna try this guy, right? So let's take a look to A. Gonna start to A, which is -6 and 8. If I use this scale factor of 1/2, what do I get for A prime? Let's say like this. I'm gonna get -6 times 1/2, -3. 8 times 1/2 is 4. So that will be -3 and 4 right here. And that will be, I will call it an A prime. Let's go to B. B is -6 and 4, -6 and 4. And again, the same scale factor, 1/2. So we're gonna have -6 times 1/2, that is -3, and 4 times 1/2 is 2. So you have -3 and 2, this one. So this is B prime. So you notice now we do have a reduction here. AB, which was 4, becomes 2 here. And obviously this is going to be B prime, C prime, which is 1. Like I said, it's a reduction, right? We can do that for C also, just to check it. C was is -4 and 4. We're gonna do a reduction by 1/2. So it becomes C prime, -4 times 1/2, -2, and 4 times 1/2, 2. Yes, that's exactly what you see here. But then what else I need to do? So I reduce it and get here, but I need to do one more thing. I need to go from here to here. And in fact, if you notice, I kind of tell you what that is a rotation. We have a rotation here. That is the transformation that will change the orientation. This A prime becomes M, right? It's a rotation 90 degrees clockwise around the origin. Let's double check that. If you remember, the rule says xy becomes y and -x. Let's take a look here. We switch these guys and then change the sign. So let's take a look. 4 and 3. Yeah, that is this point M, the corresponding point for A. So this works fine. And this one we switch 2 and -3 and change the sign. And that is 2 and 3, 2 and 3. This is this guy, notice. And obviously the last one we switch 2 and -2, and we change the sign, we get this one. So yes, we did find now the sequence of transformation. I will say is a dilation first with center of dilation of the origin, scale factor of 1/2, followed by a rotation 90 degree clockwise around origin. This is the sequence that works. I want to point something. This is one way. There might be multiple ways, and I think on the picture here, you can see another way. What did I do here? First I rotate and then I dilate it by a scale factor 1/4. So in this case, if you notice, the order is not important. Either way, we get the same picture, the same triangle. So that's it. If you enjoy this video clip, don't forget to click the like button and come back on C Squared for more help. Thank you.